Okay, so the function question in front of us is a homework question. It says identify the function's local extreme values in the given domain and say where they occur. Which of the extreme values, if any, are absolute, and support your findings by graphing the calculator or computer grapher. Okay, so if we're trying to find our extrema, we want to look at finding the derivative and finding our critical values. And because this is continuous, actually, it's not a closed interval, so it doesn't have to have an absolute max or an absolute min. Let's look at the derivative. Looking at the derivative, I'm going to need to use my quotient rule. So the derivative of my numerator is 1 times my denominator, x squared minus 25, minus my numerator, x minus 8, times the derivative of my denominator, which is 2x, all over this denominator, x squared minus 25 quantity squared. So we get x squared minus 25. Let's distribute negative 2x. So we get negative 2x squared, and that's going to be a positive 16x, all over x squared minus 25 quantity squared. So x squared minus 2x squared, that is negative x squared plus 16x minus 25. Which is the following. Negative x squared plus 16x minus 25 all over x squared minus 25. I don't see anything that multiplies to give me 25 and add to give me 16. And so I could use my quadratic formula to find out what value set that equal to 0. So negative b, negative 16, plus or minus the square root of 16 squared, minus 4 times a, which is negative 1, times c, which is negative 25. All over 2 times negative 1. So we have negative 16 plus or minus 16 quantity squared, which is 256. This is going to be minus 100 all over negative 2. So I have x equals negative 16 plus or minus square root of 156 all over negative 2. So the square root of 156 is about 12.5. So negative 16 plus my answer, divide that by negative 2, gives me about 1.755. Or 1.76. And then negative 16 minus square root of 156. Divided by 2, negative 2. That's 14.24. Let me just make sure I put that in my calculator right the first time. So negative 16. Okay. Notice that our intervals is between 0, including 0 and 5. So this value out here, 14.24, does not fall in this interval, so we're not even going to look at it. So now let's look at what's going on between 1.76. So we have 0, 1.76, and we have 5. The values where it's undefined are also critical values, but that is 5 and -5, and those are not in our intervals. So we don't even have to look at that either. So we want to see, is 1.76 a max or a min? And we can see that by seeing where it's increasing and decreasing. So let's choose a number between 0 and 1.76 and plug it into the derivative. So let's say maybe x equals 1. So plugging 1 into the derivative, we're just worried, is this going to be a positive or a negative number? So if we plug in 1, here we would have -1 plus 16 minus 25. Well, that's negative in my numerator. All over my denominator, this quantity squared is always going to make my denominator positive. So this is less than 0, it's decreasing. And then let's see what's happening f prime. Choose a number between 1.76 and 5. So let's plug in, how about 2? So we have we have 2 squared, which is 4, with a negative out front. So that's a -4, plus 16 times 2, so 32, minus 25. That gives us 3, a positive number in the numerator. All of our positive number in the denominator, this is greater than 0, so this is increasing. So I know 1.76, or approximately, that is going to be a min. Notice that if this is going to be the smallest point in that graph. So we have something that's decreasing until we hit this and then increasing. So I notice that I have an absolute min at x equals, and I don't know if they want the exact value or not, because I could technically break that down. Okay, so identify the local extreme values in the given domain and say where they occur. We're going to have to plug that back into the original to find out what the point is. If we plug in 0 there, we get 8 over 25. I'm believing that 0 is going to be a local max at x equals 0, because it's included there. And so that's going to have to be a maximum value. The thing is, it's not included at 5. And so we don't have any max or mins going to 5. Okay, so we have found those values and we had just come in and plugged those values into my math lab. And so we saw that there was a local maximum when x was 0. Plug that into the original function, we got 8 over 25. We saw that it had a local minimum. We could just plug in 8 minus square root of 39. We plug that into our original, and I just simplified a little bit. I didn't rationalize the denominator or anything, and it took it. And we also said that that local min was also an absolute min. And then we were done. Oops, I guess we're not done. We needed to choose the graph. Well, we knew what x was. It was 8 over 25. Let's blow up this a little bit. This was an absolute min. So it's either going to be A or B. B doesn't look right though. Nope. To me, maybe it's B then. Well, let's just try it. That is not correct. Oh, maybe let's pull this up. So this looks like maybe that is a min right there. It's kind of hard to tell. I know it was decreasing and then it's increasing. So this C couldn't work, D couldn't work because that's decreasing. So it must be A then. There we go.